Hey, everybody. Welcome to my talk, Multichain Multiplayer. It's going to be a talk about how we can make games multi-chain and actually maintain really strong UX properties and also security properties. I've got a lot to talk about, so I'm going to kind of rip through some of it, and hopefully I have enough time to finish it all. I'm Greg, co-founder and CPO at ChainSafe. We'll skip that because I got a lot more. At ChainSafe, we've got a bunch of different divisions: protocol development, gaming, cross-chain, interop. And in our gaming division specifically, one of the most common questions we get is, what blockchain do we build on? There's a lot of factors that come into this. There's grants you can get from the blockchains. There are different properties based on gas models. Some are cheaper, some are more expensive. Some are built around chains because of what other apps exist there for composability reasons. There's a variety of reasons why people ask this question. And we're getting to the point now where we believe that it shouldn't really matter. Pick one that makes the most sense for to run some core logic of what your game is doing, and then we can actually leverage out, because there's a fundamental problem that this question leads to, which is the minute you pick a chain, you've just isolated a vast majority of the potential user base of people who could play that game. If you go with one chain, there's 20 others that people might not, chains that exist that people might be more active on, and you're never going to get those users. And so let's kind of look at where this came from. If we look at Web 2, the model we have is client-server relationship. It's one-to-one, right? So we have a front end, we have a back end building. Similarly, post-Bitcoin, EVM kind of came to the scene. We had that same relationship because there was really just the EVM that was usable. There wasn't anything else that was a good solution to do execution as an execution environment for your code. But that's not the case anymore. Right now we've got probably a roll-up every other day that's launching with whatever it is. And so we need to start thinking about how we build applications. And this talk also applies to regular apps, but there's a really strong use case in gaming. We have to start thinking about it more in a microservice architecture or a sidecar-based architecture, which I'll get into a little bit later. But the premise that there are many optional backends that can be here, and if we treat our backends as the execution environments, so different layer 2s, layer 1s, we can get the best user experience out of it, because we can actually leverage more users and more services than whatever exists, and increase the user experience. And that's, And so what does it mean to go multi-chain, have multi-chain gaming? And what does that actually mean? So one, developers don't care what blockchain the player is using. That's an important one. A user doesn't need to learn about a new chain to play a game. They don't need to bridge to a new chain to play a game. They don't really need to do anything different than what they're already used to when interacting with the chain they're on. And key management needs to be seamless and safe. I copied this PowerPoint from a different presentation. I must have left these in. That's so funny. So to do this presentation, I'm going to be using a game that we've built internally as a demo to showcase the different types of tech you can use with our Unity SDK. And basically, this game, Block Racers, very simple game. You can race other people. 1v1, 5v5, something like that. I'm not too sure. There's a bunch of different game modes. There's a garage with a marketplace and NFTs, and you can kind of upgrade and reskin your stuff. And inside racing, there is also wager matches. So you could also put up die, for example, and the winner gets the purse of whatever was staked in there. So if 5 people put up 5 die, you can walk away with 25. Very simple game. The purpose is to demo the tech that what you can do and build with it. So let's go and upgrade this. So what does it look like today? We use scale. The reason we use scale is because of the gas properties. So scale has some funny little things with gas where the developer kind of fronts the gas. It makes for onboarding a lot easier for the end user. That's why the dev team chose that. So the current structure is this, right? So we have that client-server relationship. Let's start upgrading it. We also have a couple contracts and I'm dumbing this down a lot. we've got like a wager match, and we have a match results contract. Match results is going to be what we're going to use as our to post who won the match. In gaming, this is always like relatively centralized typically because we just post that stuff, and it's totally fine, right? Like we are using certain parts of the blockchain that we care about. Wager match is where people are going to post stake, so they're going to put money up. Currently, we are basically screwed. We can't use Ethereum, we can't use Optimism, we can't use any other chain because they cannot simply just directly interact with block racers, right? And something to note, and so what do they have to do? They'd have to do this. They have to put a bridge in the middle, which is clunky. You're now separating funds and distributing funds across different chains, which means like if they're using USDC as the stake, the unfortunate part here is now that they have less USDC on the chain that they actually want to be on, because maybe some of our users don't actually want to be on Scale. So how do we get to a situation like this, where we can actually have this like nice interaction where people can interact with the game? Oh, this is out of order. This is how wager match works. You put up 100 die. So if this is what it looks like today, right, we are going to keep the wager match and the match results on Scale. We will then, this is where it gets a little complicated, I'm sorry. We will then, what we will do is we can use a bridge in the middle to actually push data around. And now we're using the bridge as basically like our own little microservice. And we're treating all the other blockchains as little microservices. This is kind of like the, I can't remember the name, the gateway, right? There's like a gateway in microservices. Let's think of a bridge as that. On Scale, we're going to have our wager matching, and the match results should not be over there. I apologize. Ethereum has no match results. Scale's going to have all the core code, right? And then for the game. But then every other chain is going to be able to use this wager match contract. What that means is a player can go on any chain and deposit in 100 DAI if that's what they want to stake, right? So they put up 100 DAI into the wager match contract. This would then allow them to participate. When a match results get posted, the block racers game reads the state and says, oh, hey, a user just won. So what we do is we do some accounting. The bridge then does accounting cross-chain to basically resettle the balance and say, this is how much you should be rewarded based on it. And that can be also multiplied against many chains. Oh, my slides are all out of order. This is what I get for what I did. So what that looks like is this. If a person put in 100 DAI, the bridge would then just do accounting and say, you're going to lose 20. We don't have to take the DAI out. We don't have to move the DAI. The only time we'd actually have to move the DAI, this is similar to DeFi. A vault strategy is constantly re-updating. People's positions are changing. We don't have to move the DAI. The DAI is just being, when they go to exit the contract, they will then only be able to exit with 80 now. And that, if there's not 80 available in this pool, the bridge can just do a rebalance and rebalance the user's portfolio, rebalance across all the chains to get it. And then what we end up is a system like this, where match results exist here, everybody has an ability to do wager, so everybody can play the game now without ever having to bridge to another chain. So we're putting the onus of bridging onto the developer, not the user. And we can also have payouts happen globally across all of them so that the user never has to split up their funds, never has to think about how to use another wallet, doesn't have to think about gas on another chain and how they're going to handle that. Also, with bridging, are you going to get the right version of DAI, the right version of USDC, or are you going to get some weird version of USDC, then you have to find a pool and swap it for? We avoid all of this complication by letting the bridge kind of act as that gateway for us to our other microservices. And again, the game is going to read like core state stuff and whatever other contracts exist on its own from the main contract, the main chain that you chose, but you're allowing your other players to be inclusive. You're allowing them to play with you. And that is how we can do that. And I'm going to touch on like the similar concept to draw a comparison to marketplaces, right? Today, if you go to a marketplace like OpenSea and you want to go and buy an NFT, OpenSea will show you NFTs across many different chains because you can do a network switch, which is you can switch your network, see a bunch of different NFTs, add them to your cart, you switch your network again, see other NFTs, add to your cart. But when you go to check out, the entire UI is bricked because they won't let you sign a transaction for an NFT living on a different chain. And this is a fundamental issue with how we handle marketplaces. And we can use the same microservice architecture. And the reason I'm doing this is, again, the analogy back to how this bridging concept can work for just about anything. What we can do instead is follow the same patterns I showed here, which is we can have everything happen automatically for the user and settled later. So what it looks like is users can log in on a wallet from any network. Users can buy their NFTs on any chain at the same time, and we're able to do the NFT purchasing at any time by following a concept that a lot of bridging uses for liquidity, which is the idea of an optimistic purchase and settled via bridges later. This would be the idea that a paymaster, similar to 4337 paymasters or a relayer, will basically say, hey, okay, cool, we'll go and buy that NFT for you on that chain. You paid me on Optimism. The NFTs there might have been an NFT on Base and an NFT on L1. That will get paid for on the Optimism side, and then the bridge will go in, the developer of the marketplace has a bridge integrated, and it will automatically lazily settle that transaction slowly by pushing the funds to the end, to the relayers that bought you the NFTs. Now we can get collections that are multi-chain. We can get all this, and this is just by simply thinking about the UX of a multi-chain application, not saying, because a lot of teams right now say multi-chain applications are simply, oh, I've deployed my contract on every chain and you can switch networks to use that instance of it. We need to start thinking of multi-chain as a way to aggregate all the data across all of them. And so that's kind of like the gist there. Crazy time. I have 2 minutes, I think, but I'm going to try and make it 2. So let's go. Okay, so this is some internal research we've been working on and playing with. It's very much ideation, but we are probably pretty close to actually getting implementation of it. And it's just because we rely on a few external services we've been waiting to get finished. Sidecar state machines. What is a sidecar? A sidecar provides the main application with supportive features, and it's not part of the code. TLDR. It's the idea of in a microservice architecture, let's say you upload a photo to Facebook. That photo needs to be resized and compressed and enlarged for different mobile viewing options. Little small thumbnail, big photo, whatever. That doesn't happen on the main server. That gets pushed out to a sidecar that is dedicated to resizing images so it doesn't slow down the main service. That's what a sidecar does. How can we use sidecars in the previous example? So we have this previous example. We have our read writes happening. We have our time lock. Oh, I didn't talk about this. This is a time lock because someone bugged me and said this whole system doesn't make sense. When you click withdraw, there's a 24-hour timeout. So then this is how you can ensure that the game logic, again, games don't care about fully on-chain state, right? The game can say, oh, time lock is initiated. That means he can withdraw in 2 hours. The game can have an optimistic setting where it says, okay, you know what? I can settle a bridge transaction in 10 minutes so the player can keep playing the game until the timeout window hits 30 minutes, for example. So they can initiate the withdrawal sequence but continue to play for an hour and a half, and then at that point the player's like, hey, you might not have funds to settle your wager matches. Anyway, tangent. How do we upgrade this? Let's go and look at just this section. So let's look at the... Oh, that's because I hit time. Yeah. Yeah, I'll just... I know, there you go. That's it, guys. That's all, yeah. I said it was research, right? Research never finishes. Oh, it's HDMI? They don't know yet. All right. So we're going to do a little zoom in. We're zooming on the left-hand side of the screen. Bop. There we go. Nothing's changed. But the main thing to remember is match results at the bottom there only exists on scale, right? Because we're only posting the matches to one chain and settling the balances across other chains, right? Now, how do we modify this? The screen. Okay, that's fine. We can work with this. Okay, so the game's interacting with scale. Next step is what we do is we start adding rollups as a service, and like they're like almost there. They're like almost ready. Things like RollKit do exist, and what we do is game history. Now, let's say you want to have a game that like records live things. Maybe it's not block racers. Maybe it's a TCG, like a trading card game, where you want to record every single move that happens in there. Well, that's really expensive to put on a chain. But also, the game was already federated to begin with, or centralized on whatever server you're using. So let's just make a federated rollup. There's nothing wrong with that. Players aren't really going to care, and we need to like dig our head out of the idea that like we need everything super decentralized. We're going to have a rollup as a service spinning us up chains on demand for match history. In this example of block racers, maybe I want to record every single keystroke that the people make to verify that they actually made them at a certain timestamp, yada, yada, yada. So that's going to spin up. Then we're going to post that state data back into the match results one and roll, effectively doing like the roll-up mechanism. And that's our sidecar. So in this sense, we're going to have a sidecar that is basically the match data posting. What happened here? Yeah, okay, and whatever. So we have that. That's not doing anything. There we go. But then there's the question of the user. Because we talked about before how we didn't want the user to leave the game, leave their chain. But now that we have a new chain, the user does in fact have to leave the chain, right? Because they need to connect switch networks. But we can avoid that by if they go to their main chain that they're on, we add a new contract. We have a session modules manager contract. Now, you can augment those 4327. I don't really care. That's aside from the point, is the game client now registers you a session key. This now session key can be used on any chain behind the scenes because we can do blind signing. We can do whatever we want. It really doesn't matter because this isn't going to hold value. This is just a linkage in the back end for the game to be allowed you to play any arbitrary rollup that we spin up because they'll register it for you, and it's in the game client. So then what it starts to look like is the user is able to now take a session key, throw it into the rollup. Now the game client is able to do signing in the background just to make sure we can record every single key press. We don't need to click sign transaction here. It doesn't really matter. It's irrelevant. The security's fine because the session key doesn't hold value. It's literally, it could be P256. It could be any sort of hash. Doesn't matter. So that's how we've augmented the sidecar a little bit. We're going to take it a step further and look at how do we apply this to the entire system. What we have is you can see the session key managers are attached to all the different chains that we had from before. The session keys are then added into the rollups as a service. As a game wager match starts, it'll go and spawn a rollup as a service. The players will play in there. It'll get rolled up into match results. Your bridge, which is your middleware layer, is going to then go and rebalance against all your players who, based on the balance changes they have. And when a user initiates an exit, if there isn't enough balance there, again, the block racers will just re-trigger a bridge message to rebalance the entire game state across chains. And we've maintained a really fundamental property here, because you can also add in the marketplace in this if you want. I just didn't, screen real estate was running out. And the main thing we've managed to keep here is we've managed to do two things. Keep the user on the chain they were on, and increase the total amount of users that your game can now attract. And that means your game can have a way better adoption rate. And that is how we can use rollups as a service as a sidecar to your game, and also make sure that, yeah, as I said. And so this is all possible today with a little bit of engineering effort from two of our products at ChainSafe, Gaming, and collaboration Sigma, which is an interoperability layer that connects substrate-based chains, Cosmos chains, and EVM chains, focusing natively, which means we use the canonical bridging methods where it's the safest, but as well as we've got a bunch of work in the ZK side for light client proofs to make sure we can get augment that trust there a little bit better on the path of full consensus proofs. Thank you. That's my talk. We're hiring, always. And if you would like to go to a landing page for gaming and stuff, feel free to scan that. That'll do everything you need.